Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners, and welcome to today's natural sciences lesson. My name is Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are still on our term 4, exploring the knowledge area, planet Earth, and beyond. Our topic for today is about the atmosphere, where we will be talking about the layers of the atmosphere, right? Which are the atmosphere itself, the troposphere, the stratosphere, the mesosphere, and as well as the thermosphere, right? As our subtopic. So now let's quickly move on to our lesson objective to see what we need to achieve by the end of the lesson. So when this lesson ends, these are the following things that we should be able to do, right? Or that we should achieve. So when this lesson ends, we should be able to firstly explain that the atmosphere is the mixture of gases held around the earth by gravity, right? So we need to understand and be able to explain that the atmosphere is the mixture of gases held around the earth by gravity. Also, we need to be able to explain that the atmosphere has 4 layers, right? The atmosphere has 4 layers, which are the troposphere, the stratosphere, mesosphere, and as well as the thermosphere. Also, we need to be able to discuss the layers of the atmosphere, right? One by one. The troposphere, the stratosphere, mesosphere, and the thermosphere, right? We need to be able to discuss those. And also, we need to be able to explain that each layer has a different temperature gradient, right? Each layer has a different temperature gradient. We need to be able to explain that as well, right? So I hope you have your notebooks or your classwork books so that you're able to copy down some notes as we proceed through this lesson, right? And all this information now is found on the CAPS document on page 81 to page 82. Now let's move on to our pre-knowledge, right? To see which topics have we covered so far and that lay a foundation to today's topic. So in grade 4, this is when we introduced what? Planet Earth and the Sun, right? To mention that the planet and the Sun, they have a working relationship, right? They have a relationship, and we talked about the planet Earth, right? So where do we find this atmosphere now? We find this atmosphere where on planet Earth, right? Which is what we're going to discuss for today. Then also in grade 9, which is the very same grade that we are in now, we talked of the Earth as a system, right? We said that the Earth is of what? 4 different spheres, right? The lithosphere being the solid rocks and soil of our Earth, the atmosphere being all the gases around the Earth, the hydrosphere being all the waters of the Earth, be it in solid, liquid, or in a gaseous state, right? Then we talked of the biosphere, which is the relationship between living organisms and their interactions with the non-living components of our Earth, right? This is what we discussed when we talked about the Earth as a system. So today we're going to focus on this part only, which is the atmosphere, right? Which is all the gases around us or all the air that we find in our Earth as a system. Now, before that, let's engage in our baseline activity to test our knowledge so far, right? It is 2 questions, but I'm going to give you 3 minutes because the other one you have to list, right? So now, number 1 says define atmosphere. Then number 2 says name any of the gases found in the atmosphere, right? So that is all for our baseline activity. Let's take 3 minutes, then after that, we shall mark together. Welcome back, grade 9s. Please do not forget to send in your answers, your questions, or any comments on this lesson on our WhatsApp interactive number, which is 079 578 2908. If you are not sure, it is there on our screen. And now I would like for us to mark the work. Right. Number 1, define atmosphere. Right? How can we define atmosphere? So the atmosphere is defined as the layer of gases or the mixture of gases held around the Earth by the force of gravity, right? It is around planet Earth and it is held with what? By the force of gravity. Then number 2, name any of the gases found in the atmosphere, right? So the gases are oxygen, nitrogen, carbon dioxide, water vapor, and as well as argon, right? So now if you need to copy down the corrections, I'll give you a quick minute to do so. Then after that, we shall proceed with our lesson. Welcome back again, grade 9s. Now let's move on with our lesson. We're going to start off by introducing our important terminology, right? The important terms that you're going to come across as we learn through this lesson. Right. Firstly, we have atmosphere, which is our main topic for today, right? The atmosphere. So the atmosphere is the mixture of gases that is held around the Earth by the force of gravity. Also, we have air. And air is the mixture of gases that make up the atmosphere. Then we have density, right? I'd like you to pay more attention on density because we're going to learn more about density as well today, right? So density now is the amount of mass, right? The amount of mass in a given volume of a material, right? The amount of mass in a given volume of a material. Then we have troposphere, which is the lowest layer of the atmosphere closest to the Earth's surface. Then moving on, we have stratosphere, which is now the second layer of the atmosphere from the Earth's surface. Then we have mesosphere, which is the third layer of the atmosphere from the Earth's surface. Then we have thermosphere, which is the fourth layer of the atmosphere from the Earth's surface. Are we together? Then we have altitude, and altitude is the height above sea level. Then we have temperature gradient, which is how much temperature changes with altitude, right? How much temperature varies as we increase with altitude, right? Or we move away from the surface of the Earth. Right. So today's topic is mainly about the atmosphere and the layers of the atmosphere, right? So the atmosphere now, what is this atmosphere we're talking about, right? The atmosphere is simply what? The mixture of gases or the layer of gases around planet Earth, right? And this mixture of gases, they are held together or around Earth by the force of gravity, right? So now, this atmosphere is made up of air, right? Which is a mixture of gases as well, right? So this mixture of gases, they are known as what? As air. the air that you and I breathe in and out daily, right? It is of what? The atmosphere. It is all the gases that are found in our atmosphere, and they are held around by the force of gravity around Earth. Together. So the atmosphere, let's remember this, it is one of the four spheres that we have of our Earth system, right? And it is very important for many processes on Earth. To mention one, remember our example when we're talking about what? The four spheres of the Earth, right? When we're talking about photosynthesis, right? So where do these plants get their carbon dioxide to photosynthesize? They get it from the atmosphere, right? So it is important for many processes on Earth. Altogether, these different gases, they play a role in supporting life on Earth as well, right? So let's remember this. The atmosphere also is one of the four spheres of the Earth's system. So here is a picture of an atmosphere, right? The layer of gases, if you look up, you start to see what? Some clouds. The clouds as well are part of the atmosphere, right? You look around, you see the sky. It is part of the atmosphere, right? Just above what? The Earth's surface, we start experiencing what? Our atmosphere, right? All those layers of gases around us that are held by gravity that we cannot even see with our own naked eyes. Are we together? So now, without the atmosphere, because the atmosphere plays a role in providing these gases that are essential for many processes on Earth, right? So without the atmosphere, there would be no life on Earth, right? So now, let's see how is the atmosphere important now. It said it contains what? Air. And air is a mixture of different gases, right? So in air, we find gases such as oxygen, such as nitrogen, such as water vapor, such as argon, such as carbon dioxide as well, right? So our air mainly consists now of 78% nitrogen and as well as 21% oxygen altogether. The nitrogen, which also plays a role in manufacturing what? Proteins, right? And also oxygen for us to be able to breathe in and receive what? Oxygen, right? And so that we are able to carry out processes such as cellular respiration as well, right? This is how the atmosphere is important on human beings or animals or what you call what? Plants, right? So the two gases now alone, which is the oxygen and the nitrogen, they make up 99% of the air, right? And they are always present in the same proportions, meaning they are always present. When it comes to oxygen, it is always 21% of the atmosphere. When it comes to nitrogen, it is always 78% of the atmosphere. So what about the 1% now, right? So the other 1% is made up of many different gases, such as water vapor, such as carbon dioxide, including argon as well, right? So let's look at this pie chart here to look at what I'm talking about here, right? So let's say this whole pie here is our atmosphere, right? So now the 78% now of this atmosphere is taken by the nitrogen, right? Where you have now the 21% being taken by the oxygen, then the 1% being shared amongst the rest of the gases, right? Other gases such as argon, water vapor, and carbon dioxide, right? So these are the main gases that make up the atmosphere. Are we clear? These are the main gases that make up the atmosphere, right? So now I want us to move on to this part of the density of the atmosphere now. So now I said we're going to focus more on density as well for today, right? Let's first start by defining density again so that we understand what we're talking about. So as I said also in the terminology, I said that the density is what? Is the density of a material describing what? The amount of mass in a given volume of that material, right? So when talking about density, we are talking about the amount of mass, right? The amount of mass in a given volume of that material, right? Are we together? That is what we mean when we're talking about density, right? The amount of matter or the amount of mass in a given volume of what? That material. So in the atmosphere now, most of the mass of the atmosphere lies less than 10 kilometers above the Earth's surface. So meaning what? This is where we find most of the air, just above the Earth's surface, right? In less than 10 kilometers, this is where we find most of the air particles. This is where it is mostly dense, right? This is where we find most oxygen, most nitrogen, and all the other gases in our air. Are we together? So the density of gas particles decreases now as we go up with altitude, right? The density of the gas particles decreases, or it goes down, right, with distance from Earth, and air gets thinner and thinner as we increase with altitude, right? So eventually the density will become too low that the atmosphere just blends into space, right? So let's look at what we are talking about here, right? So the atmosphere, we said that it is a mixture of gases, right? And this atmosphere has different layers, right? And now we're talking about the density of the atmosphere. We are saying that it is mostly dense at less than 10 kilometers above the Earth's surface, right? So looking at our graph here, right, we have altitude in kilometers, then we have pressure and relative density, right? So now we are saying that it is mostly dense at less than 10 kilometers above the Earth's surface, right? So from our graph here, this is our Earth's surface, right? This is our ground, right? This is our crust probably, right? So now, from 0 going upwards, right? And right there at 10 kilometers, right? This is where we find most of our density. Let's look at this and analyze it, right? Let's go all the way to relative density. So now, when we get to relative density on our graph, can you see that now there is more black dots, right? Those black dots, they represent what? Our air particles, right? They represent our gas particles. And as we can see here now, they are mostly embedded here, right? They are mostly found on this space at 0 to 10 kilometers, showing that there is more density of the gas particles or of the air right at this point, right? Which is at our first layer of the atmosphere, being the troposphere, right? This is where we find the richness in oxygen, right? The richness in what? In all these gas particles, right? Because this is where they are mostly dense. Are we together? So as you can see now, from that point of 10 kilometers, going upwards now, the black dots start to be fewer and fewer, right? They represent what again? The gas particles. So meaning what? It becomes less dense now as we increase with altitude. Are we together? So now, talking about the layers of the atmosphere before we incorporate it with the density, right? The layers of the atmosphere, there are 4 main layers, right? Namely, the troposphere, the stratosphere, the mesosphere, and as well as the thermosphere, right? So here is a picture to illustrate what I'm talking about, right? This is the Earth, right? And the surface of the Earth, right? So as we move from Earth now, from the Earth's surface, going upwards now, we start to experience our atmosphere, right? All the layers of gases held around by gravity around Earth, right? So from 0 to 10 kilometers, we find the first layer having the most density, right? The first layer having the most density of gas particles being the troposphere, right? We find it along what? 0 to 10 kilometers above the Earth's surface. Then moving on now from that 10 kilometers going upwards again, right? We are increasing with altitude. Remember, as we increase with altitude, the density of the gas particles starts to do what? To decrease, right? The gas particles start to become fewer and fewer, right? So from 10 to 30 kilometers, we find the layer of the atmosphere that is called the stratosphere. and it is the second layer from the Earth's surface as we increase with altitude, right? Then as we increase with altitude again, the density of the gas particles decreases, right? Becomes what? Lesser and lesser. Then from that 30 kilometers to 50 kilometers, we find the third layer being the mesosphere, right? Then that 50 kilometers going upwards with 50 to 400 kilometers of altitude, we find what? The thermosphere, right? The thermosphere layer of our atmosphere. Then from there on now, we find a layer that is not mostly mentioned in our lessons, which is exosphere, right? So exo means exit, right? Or out. So it is the outer sphere that exits us into space. Are we together? And we find the exosphere from above 400 kilometers, right? But for today, we're going to dwell more on the first four, right? The troposphere being the first layer from the Earth's surface, stratosphere being the second layer, mesosphere being the third layer, and thermosphere being the fourth layer, right? So now, let's look at the temperatures now in these different layers, right? We're going to talk about now the temperature gradient in each layer, right? How are the temperatures as we go with altitude, right? How are the temperatures at the stratosphere? How are the temperatures at the mesosphere? And how are the temperatures at the thermosphere, right? We're going to look at each layer. So now the temperature of the atmosphere is not constant, right? It is not the same throughout, meaning if you find 30 degrees along the troposphere, you're not going to find 30 degrees along the stratosphere, right? That's what it means, right? So in some layers, it increases with height above sea level, and in other layers, it decreases. What we mean by that, we mean that in one layer, you find that temperatures are too high. In the next layer, the temperatures are too low. In the next layer, they are too high, and the following one, they are too low, right? That's what temperature gradient in the atmosphere is all about, right? And also let's remember height above sea level is called altitude, right? So now we're going to talk about how much temperature changes with altitude as we increase with the layers, right? So let's look at this graph to analyze what we're talking about here, right? So this graph talks of temperature, right, in degrees Celsius. Then we have altitude, which is the height above sea level, right? So it is a temperature versus altitude graph, right? So also now we have some labelings of the different layers that we find in our atmosphere, starting off with the first one, the troposphere, second one being the stratosphere, and the third one being the mesosphere, and the fourth one being the thermosphere. And our focus now is the temperatures along where? Along these layers, right? So if you look at the scale of our temperature, it starts there by minus 100, minus 80, minus 60, 40, 20, 0, up until 40 degrees Celsius, right? So what happens now? What happens here? We said that as you increase with altitude, the temperatures, they vary, right? They vary from layer to layer, right? So as you can see here now, as we increase with altitude along the thermosphere, what happens? Along the thermosphere, the temperatures, they drop, right? They move from 0 degrees to a negative 60 degrees Celsius, right? Then from our thermosphere, when we reach the stratosphere, the temperatures start rising, right? They start rising as they rise from that 60 degrees, negative 60 degrees Celsius to a 0 degrees Celsius. So the temperatures are increasing, right? It starts to become hotter, right? Then as we reach the third layer of our atmosphere, which is the mesosphere, the temperatures drop again, right? From that 0 degrees Celsius to about what? To about a negative 100 degrees Celsius, right? This is the coldest layer that we find in our atmosphere. Then from that negative 100 degrees Celsius, the temperatures as we reach the thermosphere, they increase, right? They increase from that negative 100 to at least what? Negative 20 degrees Celsius, right? So that is what temperature gradient is about in as far as the atmosphere is concerned, right? The variation in temperatures as we increase with altitude from layer to layer, right? So as we can see from the troposphere, the temperatures drop or they decrease, right? When we reach the stratosphere, the temperatures go up. When we reach the mesosphere, the temperatures drop again. And when we go up with the thermosphere, the temperatures go up as well. Are we together? So now let's move on and test our knowledge so far by writing activity 1, right? Number 1 says, what holds the atmosphere around Earth? Number 2, which two gases make up most of the gases of the atmosphere? Number 3, how does the density of the atmosphere change with altitude? Number 4, in which layer does the Earth's weather occur? Then number 5, why is the ozone layer important? All right. So let's quickly pause the let's quickly take 5 minutes to write down the answers. Then after that, we shall mark together. Now, welcome back, grade 9s. Let us look at the solutions together. Number 1 says, what holds the atmosphere around Earth, right? So the atmosphere is held around Earth by the force of gravity, right? The force of gravity. And number 2, which two gases make up most of the gases of the atmosphere? Those gases are the oxygen and the nitrogen. And number 3, how does the density of the atmosphere change with altitude, right? So as we increase with altitude, the density does what? Decreases, right? Then number 4, in which layer does the Earth's weather occur, right? It occurs on the first layer from the Earth's surface, which is the troposphere, right? Then why is the ozone layer so important, right? It is important because it protects life on Earth from harmful UV rays from the sun, right? Are we together? So these are your corrections, and if you need to copy them down, please take a minute to do so. Then after that, we shall continue with our lesson. Welcome back again, grade 9s. Now let's move on with our lesson. Right. So now let's discuss these layers one by one, right? Starting by the troposphere. Remember, the troposphere now is the first layer from the Earth's surface, right? Or it is the lowest of the atmosphere's 4 layers. Are we together? So now, this layer, it extends from the sea level or with altitude from 0 to 10 kilometers above the Earth's surface, right? This is where we find our precipitation. This is where we find our clouds. This is where all weather occurs, right? Our troposphere, right? As you can see here, this is our Earth's surface, right? The Earth's surface. This is this point, right? Then from this point here, going upwards or above sea level, right? As we go up, we find our layer of the atmosphere being the troposphere up until 10 kilometers with increase in altitude. Are we together? So as I've said, that the troposphere, this is where we find all our precipitation, all our cloud formations, all our different clouds, to be exact, right? So now, let's look at the mass and density of the troposphere now, right? So the troposphere contains more than 70% of the mass of the atmosphere, right? Because this is where it is mostly dense, right? So this means that that 70% of all gas particles are located within 10 kilometers of the Earth's surface, right? This is where we get most of our air, right? In terms of mass, right? So density decreases with height within the troposphere too, right? So as we increase with our troposphere, right? Let's look at this diagram. This is our 10 kilometers here, right? Going that side, looking at density, right? You can see that also along the troposphere, the density decreases, right? Because when you're looking at the black dots here, as you go up, they start to become scattered and few, right? But from 0 to 1 kilometer, 2, 3, 4, 5, it is mostly dense, right? It is mostly dense. But from there on, going upwards until 10 kilometers as well, we start to notice change, right? So meaning what? density decreases with altitude as well in the troposphere. So what about the temperature gradient of the troposphere now, right? So temperature in the troposphere decreases as the distance above the Earth's surface increases, right? The temperatures start to drop as we go up with altitude within the troposphere, right? So this explains why there's often snow on the top of a mountain, but less snow or no snow at its base, right? Let's look at some example here, right? We have Mount Kilimanjaro, right, and Mount Fuji, right? So as you can see here, right, as you can see here, Mount Kilimanjaro has what? Some snow at the top of the mountain, right? Because now it is experiencing extremely cold temperatures at the top. Whereas at the bottom, there is less snow, right? It is within what? It is also, it is almost what? Sorry, it is on the Earth's surface, right? But as we increase with altitude now, the temperatures drop, right? So hence we experience what? More snow on the top of Mount Kilimanjaro and as well as Mountain Fuji. Are we together? Right. So now moving on, right? Let's move on to the weathers that occur in the troposphere, right? So weather occurs in the troposphere, as I've said, this is where we experience our temperatures, this is where we get our form of precipitations as well, right? So the troposphere is the only layer in which clouds form and different kinds of precipitations like rain, hail, and snow fall to Earth. Are we together? So here are the different clouds that we can find in the troposphere. To mention some, we have some nimbostratus clouds, some stratocumulus, cumulonimbus clouds, cirrocumulus, cirrostratus, and all the types of clouds they form where? In the troposphere layer of our atmosphere, right? So now, also, as I've said, that this is where our precipitation forms, right? So this is where now what certain processes of the water cycle take place, right? Because almost all the water vapor in the atmosphere is found in the troposphere. And where is the water vapor coming from, right? From the evaporation of water from our seas, right? To form clouds, right? So that we can experience rains, right? And water vapor is carried upwards by rising air. Air that rises through the troposphere stops rising when it reaches the stratosphere, right? So also with that being said, all animals and plants, they live in the troposphere, right? But also some birds do fly higher than their upper limit occasionally, right? So the troposphere is the only layer in contact with the hydrosphere or the other spheres of the earth, right? The hydrosphere, the lithosphere, and as well as it can be part of the biosphere, right? Because it accommodates living organisms as well, and the living organisms, they interact with it, which is non-living, right? So it is in contact with the hydrosphere, all our waters, and the lithosphere, all the solid rocks and soils of our earth, right? So even within the troposphere, life is mainly found in the lowest 2 kilometers closest to sea level, right? It is talking about you and I now, right? Which are on the ground, right? So now, moving on to the second layer above the Earth's surface, which is the stratosphere, right? So the stratosphere now is a layer of the atmosphere that is above the troposphere, and it extends from the 10 kilometers where the troposphere ends, from that 10 kilometers to about 50 kilometers above the Earth's surface, right? And the air in the stratosphere is very thin compared to the air in the troposphere. Why are we saying that? Because now as we move higher with altitude, the density of the atmosphere decreases, right? So also the stratosphere now is where we find some aeroplanes flying like commercial jets and other airplanes, right? They're able to fly in our stratosphere. So looking at this picture here, right? We can see that the airplane is above the clouds, right? This shows what? That we are on the next layer now, which is the stratosphere. because we said that these clouds, they are found where? Along our troposphere, right? They are found in our troposphere. All types of clouds, they form where? In our troposphere. Just above now the clouds, we start to experience what? The stratosphere, where airplanes fly as well, where the air is getting thinner and thinner, right? Because of what? The decrease in density. Right. So now also there is a special layer that is found in the stratosphere that I would like for us to talk about, right? The layer of the stratosphere is called the ozone layer, right? So it is a band of ozone gas, right? It is known as the ozone layer. And the ozone layer is the form of oxygen in which the molecules have 3 atoms of oxygen, right? Instead of the usual 2 atoms altogether. So it is having what? 3 atoms of oxygen and written as O3. So the ozone layer now is there for a specific reason, right? The ozone layer now, we find it where? At about 10 to 40 kilometers above the Earth's surface, in the lowest part of the stratosphere, right? It is therefore an important role to be able to absorb the sun's harmful UV rays, right? It absorbs the sun's UV rays so that we do not experience too extreme what? Hot temperatures, right? And also it absorbs the UV rays so that also we do not lose heat at night, right? So that we do not get cold at night, right? When there is no sun altogether. So hence the absorption of the ultraviolet radiation warms the stratosphere, right? So looking at this picture here is our planet Earth. Just above planet Earth or around, right? We find the first layer of the atmosphere being the troposphere from 0 to 10 kilometers. Then from 10 kilometers to about 40 kilometers, right? To about 40 kilometers here, we find the ozone layer, right? The ozone layer, mind you, is within the stratosphere layer of the atmosphere. And the ozone layer serves as well as it serves as protection, right, against the sun's harmful UV rays, and also protect us from getting extreme cold at night, right? So it traps the heat so that we sustain good temperatures, right? So that we do not get extremely hot temperatures during the day and we do not get extremely cold temperatures during the night. Right. Now moving on to the third layer of the atmosphere, being the mesosphere, right? It is the third layer from the Earth's surface, and this one now extends from about 50 kilometers to 80 kilometers above the Earth's surface. And the air now is extremely thin in the mesosphere, right? It is extremely thin because of what? Of the decrease in density, right? As we move up with altitude, the air gets thinner and thinner. But also there is one thing about the mesosphere, right? It is the coldest layer that we experience. This is due to the temperature gradient we were talking about, right? It is due to the temperature gradient. Hence, we mentioned that the temperature varies from layer to layer as we increase with altitude, right? And the troposphere, we start to experience what? The decrease in temperature. Then when we enter the stratosphere, there is an increase in temperature. Then when we enter the mesosphere, there is a decrease again in temperature, right? So the mesosphere, it is extremely cold, right? Because temperature decreases with altitude in this layer of the atmosphere. And the top of the mesosphere now is the coldest part of the atmosphere with temperatures as low as negative 90 degrees. Now moving on now to the last layer of the atmosphere, being the thermosphere, which is on top of the mesosphere, right? This one starts at about 80 kilometers above the Earth's surface, right? And it has the highest temperatures, right? The temperatures increase with altitude in this layer of the atmosphere. And the amount of gas in this layer gets less and less, diminishing slowly until space begins at about 350 kilometers above the Earth's surface, right? This is where we get the thinnest of our air, right? And also we find satellites orbiting in this layer away from the Earth's surface, right? So there are thousands of artificial satellites in orbit around Earth, right? And they're all found in our thermosphere. So now moving on to our activity 2, it says copy and complete the table below. Indicate which layer in the atmosphere the characteristics in the left-hand column referred to by placing an X in the row under the heading for that layer, right? So I'm going to give you 5 minutes for this activity. Then after that, we shall do the corrections together. Welcome back, grade 9s. Now we're going to look at the solutions together. Remember, do not forget to send in your answers, your questions, or any comments on our WhatsApp number, which is 079-578-2908. Right, looking at our table, on the left-hand side, we have what? Or left-hand column, we have temperature decreases with altitude. Temperature increases with altitude, contains the ozone layer. Clouds form in this layer, then has the highest temperatures, right? So which of these layers has the following characteristics, right? So now, temperature decreases with altitude, right? Starting off with the troposphere, right? As we said that on the troposphere, the temperatures, they decrease as we go high with altitude, right? And also temperature decreases with altitude in the mesosphere, right? Then moving on to temperature increases with altitude. Temperature increases with altitude in our stratosphere, right? And as well as where? In our thermosphere. Then contains the ozone layer. Which layer of the atmosphere contains the ozone layer? That one is the stratosphere, right? It is the stratosphere. Then clouds form in this layer. In which layer where clouds form, right? It is the troposphere, right? All types of clouds, they form where? In this layer, which is called the troposphere. Then has the highest temperatures from our graphs. It is what? The thermosphere, right? So that is all for our corrections. If you need to copy them down quickly, I'm going to give you a minute to do so. Then after that, we shall wrap up our lesson. Welcome back again, grade 9. I hope you had enough time to copy down the corrections. And now let's wrap up our lesson by summarizing what we have learned for today. So today's topic was about the atmosphere and the layers of the atmosphere, right? We said that the atmosphere is the mixture of gases held around the earth by the force of gravity, right? And the mixture of gases is known as air, right? And in our air, we find what? Gases such as oxygen, carbon dioxide, water vapor, argon, right? And also, the atmosphere, it is one of the 4 parts of the Earth's system and is important for many processes on Earth, right? So without the atmosphere, there would be no life on Earth, right? And also, we talked about what? The 4 layers of the atmosphere. We said that the layers are the troposphere, the stratosphere, the mesosphere, and as well as the thermosphere, right? So looking at our planet Earth, right, and its surface, right, the troposphere is the first layer that we find as we increase with altitude. It is extending from 0 to 10 kilometers above the Earth's surface. Then above the troposphere, we find the second layer, which is the stratosphere at from 10 to 30 kilometers. Above the stratosphere, we find the mesosphere layer at 30 to 50 kilometers. Then after that, we find what? From 50 to 400 kilometers, our thermosphere. Then also we find our exosphere, which is exiting us to the space, right? Which is the exiting layer to space. And also we talked about the density of the atmosphere, right? Where we said that the density of a material describes the amount of mass in a given volume of that material. And in the atmosphere, most of the mass of the atmosphere lies less than 10 kilometers above the Earth's surface. So it is mostly dense where? In the first layer, which is the troposphere, right? So the density of gas particles decreases with distance from Earth, and air gets thinner and thinner. So the more and more we increase with altitude, the more we receive what? Or we experience thinner and thinner air, right? So it gets thin eventually to a point where the density is so low that the atmosphere just blends into space, right? So looking at our graph again, this is where we find what? Our most density, right? This is the most dense part of our atmosphere. Right. So now it seems like there is no interaction on our WhatsApp number. So we're going to skip this slide and we're going to look at what we're going to be learning about in the next lesson, right? So in the next lesson, we'll be discussing the greenhouse effect, right? So at this point, we know what to do. We go home, we open our books and this topic specifically, so that when we come back here, it is an easy teaching and learning process, right? So always be ahead. I hope you've enjoyed today's lesson. From me to you now, let's head to the stratosphere and goodbye.